Hey guys, this is Carrie, and in this video we're doing the answer key to homework number 5. So a parabola has its focus at 4, 9, and directrix at y equals 1. The equation of the parabola could be which of the following. So you always want to draw a sketch for these. And your sketch does have to be a little neater than normal. So you've got y equals 1, so you go to 1 on the y-axis, and draw the line y equals 1. This is called the directrix, right? Next step, you need to graph the focus. So the focus is at 4, 9. So 1, 2, 3, 4. We already have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have our our focus at 4, 9. So in order to draw the parabola that's equidistant to these two objects, we have to find the total distance here. So because this is 1 and this is 9, the total distance is 8, which would mean for the vertex to be directly in the middle, the vertex would have to be half of this distance, 4. So 1, 2, 3, 4 above the line and 4 below the point. That would make it at 4, 5. And now you can sketch in the rest of the parabola, remembering that the parabola wraps around the focus. So now we've got our parabola graphed. So y equals, the x shift is going to be 4, so it's going to be x minus 4 inside of the square, and up 5, so the outside transformation is up 5. And for the coefficient here, the value that goes there, we use the formula 1 over 2 times the total distance. So we computed before that the total distance was 8, so it'll be 1 over 2 times 8. So it'll be 1 over 16. Now the last thing to think about, is it going to be positive or negative? Because it's concave up, this is a positive a value, and so we end up with this as our final answer, choice 2. I'm going to do problem number 2 as well. So for problem 2, we've got a parabola has focus at 2, negative 11, and directrix at y equals negative 3. So we go 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so we draw our focus down here. So I'll use green for the focus like we did before. Our directrix is going to be at y equals negative 3. So negative 1, negative 2, negative 3. And now we need to find where our vertex is. So to find our vertex, the total distance between negative 3 and negative 11 is 8 units. So our vertex has to be 4 units from each of them. So 1, 2, 3, 4. And that means it's going to be 4 units above negative 11. So 2, negative 7, and that should be 4 also below negative 3, and that works. Negative 7 does work. So we draw our parabola in. I drew it incorrectly. So why is that incorrect? Hopefully you realized that's supposed to wrap around the focus, so it's actually concave down this time. So the equation of our parabola is going to be y equals x minus 2 to move it in the inside direction, the x direction, and then down 7 is going to be an outside transformation of down 7. To compute the coefficient here, you do 1 over 2 times the total distance. That's going to be 1 over 2 times 8. That's going to be 1 over 16. And the last thing to remember is because it's concave down, there's no part of the formula that tells you this, but you have to remember that it's going to be a negative a value because it's concave down. And so that's going to be choice 2. Alright, choice 3 is really similar, so hopefully you guys can figure this one out. There is an interesting twist about the location of the vertex, which hopefully you'll be able to figure out. Number 4, you're also going to figure out. Number 5, let's figure this one out together. So a parabola has equation y equals 1 over 32, x minus 1 squared, minus 4. So that actually already tells us a lot about the parabola. And I think it's helpful to have a sketch, again, for this problem. So we're going to go 1 in the x direction, and then down 4 in the y direction. And so this is actually coming from the equation of the parabola, so this is going to be the vertex of the parabola. Now next up, it's going to be concave up, so I'm going to sketch it in concave up because it has a positive a value. And then we know that the directrix is at y equals negative 12, so negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11, negative 12. And so sketching that in, we've got our directrix down here at y equals negative 12. So finally, putting it all together, the distance between the vertex and the directrix is 8 because of negative 4 and negative 12. And so we have to go 8 higher to get to the focus, so that's exactly in the middle. And so 8 higher than this is going to be that point 1 comma 8 higher than negative 4 is 4, so 1, 4. All right, so the focus is right here at 1, 4. Now for the next one, problem 6, is going to be very similar, but you're going to be finding the directrix instead. And I'll leave this as a bit of a challenge for you because the equation of the directrix is not going to be coordinates, it's going to be a horizontal line. So think about what might your final answer look like. And you can check that with problem number 5 since you have some examples of what a directrix equation looks like in all of these. All right, guys, see you in class tomorrow.